The difference with this example is that the directions are given in cardinal directions. So it'll be a little bit different. Let's start by breaking out the first one into x and y. And then we have 2. We're going to draw x, which is our adjacent, and y, which is our opposite. But we need to know theta. So, just like in the other ones, we can draw a coordinate system to help us with this. It's 70 degrees west of north, and remember I told you to read that as west from north. So north to the west. So that angle is 70 degrees. But in our triangle, we have this angle. Well, we know that between west and north is 90 degrees. If this is 70 degrees, then this has to be 20. So our theta is 20. So now we know how to solve for our x and y. We do the cosine of theta equals adjacent over hypotenuse. And that tells us that our x is 1.9, and because it's pointing towards west, and we can still, our positive negative convention is still the same, still follows what we've learned in math class. So x is negative 1.9, and we would normally say at 180, but because we're using cardinal directions, we would say west. I will let you know that at this point, you can use west or 180, whichever one you feel more comfortable with. It's only in your final answer that I need to make sure that you are answering with cardinal directions. So we have the sine of 20 equals opposite over hypotenuse. So we have 0.68, and it's pointing upwards, so we know that that's positive. 68 at either north or 90 degrees, whichever one you prefer. So let's do the second one. Not really enough room over there, so 2. We have our x, which is equal to our adjacent, because that's our theta, and y, which is our opposite. In order to find theta, we look up at this. It's south of west, or south from west. So this angle is 65 degrees, and this is the same angle in our triangle. So we can use cosine of theta equals adjacent over hypotenuse. So we get 0.85. And because it's pointing to the west, it's going to be negative as well. And for y, we would do the sine of 65 is equal to opposite over hypotenuse. And we get 1.8. And because it's pointing downwards towards the south, it would be negative. Now we could get the sum of these two. For x, we would have negative 1.9 plus negative 0.85, and we get negative 2.75. And because it's negative, we would know that was at west. For y, we have positive 6.8 plus negative 1.8. We get 1.12, and it'd be negative 1.12. And that negative tells us it's at south. So here's our sums. And we can draw those. Our x goes to the west, 2.75. and our y goes to the south 1.12. The result is here, and our theta is there. So to find the result, we do 2.75 squared plus 1.12 squared equals c squared. And get 2.97, or you can round it to 3.0. And to find theta, we go over here and do tangent. Theta equals opposite over adjacent. So our theta is 22 degrees. But remember, you don't want to put this in unit circle. You want to put it in cardinal directions. So east, north, west, and south. And we know that this is 22 degrees. So we can say that to get to our resultant, you go 22 degrees south from west. So your answer would be 3.0 at 22 degrees south of west. And the cardinal directions can be tricky until you practice them a little bit, but if you need help with them, please ask.